All right, this is pre-calculus note 6.1 on evaluating trig ratios. Today is February 29th, 2016, period 2. Everybody in this class knows that they are being recorded. Okay, so in this lesson we are going to use numbers that are in the given diagram to calculate and simplify trig ratios. So we know from our previous video the definitions of all of our trig ratios, and now we are just going to put them into use to come up with numerical values. So I'm starting with sine, and you have to have these definitions of the trig ratios memorized. Sine is opposite over hypotenuse, and we're going with the angle, or the side opposite the angle theta, okay? We're taking the sine of theta, so that's how you know which is opposite, which is adjacent. So opposite theta is 4, and the hypotenuse is 5. That's opposite over hypotenuse. Cosine is adjacent over hypotenuse. Cosine of theta. So we're looking for the side that is next to, adjacent, as on the numerator. And then the hypotenuse is 5. And tangent is opposite over adjacent. So I've got opposite, which is 4, over adjacent, which is 3. All right, and then the next 3 trig functions are the reciprocals of those. So cosecant is the reciprocal of sine, so it's 5/4. Secant is the reciprocal of cosine, that's 5/3. Cotangent is the reciprocal of tangent, that's 3/4. All right, so this problem is just like the previous one. I'd like for you to try that by yourself before you look at my answers. All right, so pause the video, do the problem. All right, so here are my 6 trig ratios. Oops, I'm starting with sine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then the reciprocals. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. You have to have these memorized. The reciprocal of tangent is cotangent. Check your work. All right, so now with this problem, we've got some radicals, which means we're going to have to rationalize. It's very normal, of course, because of Pythagorean's theorem, to have radicals as your side lengths. All right, so sine of theta. Now, where is theta? You know, theta doesn't always have to be in that same reference spot. So in this case, theta is in a different position than we're used to. So if I'm looking for the opposite, okay, I just have to say, well, it's across from, not one of the 2 adjacent sides. So I've got sine of theta is opposite over hypotenuse. Okay, you can never leave a radical in the denominator, so this has to be rationalized. I'm going to multiply top and bottom by the square root of 7. Which equals square root of 21 over 7. sine in simplest form is square root of 21 over 7. Cosine is adjacent over hypotenuse, so that would be 2 over the square root of 7. Again, I'm going to rationalize. So I have 2 square root of 7 over 7. Tangent is opposite over adjacent, so that would be square root of 3 over 2. And here I don't have any radical in the denominator, so I don't have to worry about simplifying that. So here are my 3 reciprocals now. So cosecant is the reciprocal of sine. Now, you never want to go back to, or you never want to use the rationalized version to find your reciprocals. You always want to go back to the unrationalized version. So I want to look at this, not the rationalized one, to find my reciprocal. So I've got square root of 7 over square root of 3, and this time I'm going to multiply top and bottom by radical 3, so it's going to calculate differently. So I've got square root of 21 over 3. Secant. Okay, so I want to go back to the pre-rationalized. The pre-rationalized version of cosine, which is square root of 7 over 2. All right, so in this case, when I take the reciprocal, my denominator now is a whole number, so I don't have to worry about rationalizing that one. And then tangent is the reciprocal of cotangent. I meant that, you weren't paying attention. Cotangent is the reciprocal of tangent, so I've got 2 over square root of 3, which I'm going to rationalize. So that gives me 2 radical 3 over 3. All right, so now in this problem, we've got some decimals. If you're given a decimal answer for one of the side lengths, you are allowed to use a decimal for your answer. And so the directions say 4 places after the decimal. What you are not going to do for this problem is you're not going to punch 48 into a calculator. We'll do those problems in the next lesson, okay? Right now you are using the side lengths to calculate. All right, so sine of, oops, maybe I should undo that. I didn't take my numbers with me. Oh, undo that. Sorry, technical difficulties. Sine of 48. Okay, so I'm not using the variable theta right now because the angle is labeled with a measurement. Okay, so we're using that measurement. Sine of 48 degrees is opposite, which is 4, over hypotenuse, which is 5.4. All right, so again, your angle is not always in the same place. Your hypotenuse is not always in the same place. I'm just using a calculator. 4 divided by 5.4 gives me 0.7407. Cosine of 48 is 3.6, that's the adjacent side, over 5.4, which is 0.667. Oh, no. 0.6667. It's actually 6 repeating, but you have to use your rounding skills. Tangent of 48 degrees is opposite over adjacent. So that would be 4 over 3.6. Okay, 4 divided by 3.6 is 1.1111. Great, so now the reciprocals, cosecant of 48 equals the reciprocal of sine, 5.4 over 4. 5.4 divided by 4, 1.35. Secant is 5.4 over 3.6. Which is 1.5. And cotangent, the reciprocal of tangent is 3.6 over 4. That's 0.9. All right, that's it. Do bookwork.